So for a brief second, we're going to move back to 12.5, and you might be asking yourself, Mr. Swenson, why are we doing 12.5? We are just talking about level 13 and probability and permutations combinations. Well, as you shall see in this section, 12.5 is kind of silly because they say, hey, we're going to talk about this notation, n over j, and it's n factorial over j factorial minus n minus j factorial. And if this doesn't look like a combination, because it should, and it is. So the binomial theorem is all about using combinations to figure out the coefficient in front of a given spot. So with that all being said, if I said 3 over 1, this is 3 choose 1, which is 3 factorial over 1 factorial, 3 minus 1 factorial, which is just 3. If I have 4 choose 2, we have 4 factorial over 2 factorial, 4 minus 2 factorial, which is 4 factorial over 2 factorial, 2 factorial, which is 6, I believe. Let's just double check that. If I go to my calculator and I do 4 choose 2, we get 6. If I have 8 choose 7, I have 8 factorial over 7 factorial, 8 minus 7 factorial, which is 8 factorial over 7 factorial, 1 factorial, or just 8. And let's just double check that with the calculator. 8 choose 7, just gives me 8. Now, with that all being said, if I set this up into something called Pascal's triangle, we have 0 over 0, 1, 0, 1, 1, 2, 1, 2, 0, 2, 1, 2, 2, 3, 0, 3, 1, 3, 2, 3, 3, 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. With that being said, what's happening here is I'm going to actually take a separate sheet of paper just for right now, and this is what a mathematician called Pascal discovered. So if you start with a triangle and on the outsides you have 1 and you have 1 and add these two together, you get 2 and then 1. 1, add these two together, add these two together. Again, Pascal's triangle. The next one would be 1, 4, 6, 4, 1. The next line would be 1, 5, 10, 10, 5, 1. The next line would be 1, 6, 15, 20, 15, 6, 1. I could keep going. 1, 7, 21, 35, 35, 21, 7, 1. Now, if you look down the diagonals, these are all 1s. 1, 2, 3, 4, 5, 6, 7. This is our 0th row. This is our first row. This is our second row, third row, fourth row, fifth row, sixth row, seventh row. We could keep going on and on and on. What's important about Pascal's triangle are these are the base coefficients when we're expanding something like x plus y to the nth power, where n is one of these. This is the really powerful thing about these combinations that we have. We are allowed to expand a binomial. Now remember, you've learned the word binomial since you were a 9th grader. Binomial means 2 terms, usually x plus or minus y to some power. So what they have is x plus a to the n is n to the 0th, n to the 1st. And what happens here is we have x to the n, and then we have an a to the 1st, then we have an a to the 2nd, then we have an a to the 3rd. And as the a's powers increase, the x's powers decrease. Now this may seem weird for right now. We're going to try a couple of these out and hopefully it makes more sense. What I really do want you to know is Pascal's triangle and how to create it. So we're going to try with example 2 and example 3 to use the binomial theorem to expand out these two binomials. So before you would write it 5 times and then FOIL it each time. This is supposed to make your life a lot easier. So this is to the 5th power. If you go to the 5th column, we are going to be using these coefficients. You could use the formula on the front, which says n over j, and then you go n to the 0th, so like 5 over 0, then 5 over 1, then 5 over 2, 5. Like, you could write this. We would have 5, 0, x to the 5th, 2 to the 0th, plus 5, choose 1, x to the 4th, 2 to the 1st, plus 5, 2, x to the 3rd, 2 to the 2nd. See that these are, as the x's go down, the 2's go up. These are all multiplied, plus 5, 3, x to the 2nd, 2 to the 3rd, plus 5, 4, x to the 1st, 2 to the 4th, plus 5, choose 5, x to the 0th, 2 to the 5th. Now we could write out all of that, but we already have done this. This is 1, this is 5, this is 10, this is 10, this is 5, this is 1. These are all of the coefficients from the 5th line of Pascal's triangle. Now this is x to the 5th, 2 to the 0th, which is 1. This is 5 times x to the 4th times 2. This is 10 times x to the 3rd times 4. This is 10 times x squared times 8. This is 5 times x times 16. And this is 1 times 1 times 32. These are all pluses in between. If these were a negative sign, we would just alternate, which makes sense. So this would be x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 5 times 16 is 80x plus 32. This is that binomial fully expanded with very little stress. We are going to do the same thing with example 3. I'm going to write it out using the binomial theorem. So we have 4, choose 0, and then this is 2 to the y to the 0th, to the 4th, negative 3 to the 0th, plus 4, choose 1. Then we have 2 to the y cubed, negative 3 to the 1st, plus 4, choose 2, 2 to the y squared, negative 3 squared, plus, should write a little smaller, 4, choose 3, 2 to the y to the 1st, times negative 3 to the 3rd, plus 4, choose 4, 2 to the y to the 0th, and that's negative 3 to the 4th. So, again, if we go to line 4 of Pascal's triangle, this is 1, 4, 6, 4, 1. 2 to the 4th, y to the 4th, is 16y to the 4th. Negative 3 to the 0th is 1, plus 4 times 8y cubed times negative 3, plus 6 times 4y squared, negative 3 squared, which is 9, plus 4 times 2 to the y times negative 27, plus 1 times 1 times negative 3 to the 4th is 81. So this all together is 16y to the 4th plus negative 12 times 8 is negative 96 y cubed plus 36 times 6 is 216 plus 8 times negative 27 is negative 216y plus 81. You see y to the fourth, y to the third, y squared, y 0. And so if I really wanted to write this nice and clean, that'd be 16y to the fourth minus 96y cubed plus 216y squared minus 216y plus 81. This here is my answer. Now, if I want to find the coefficient and not expand everything else out of y to the 8th, I'm going to flip this over just so we can see. This is how I figure out which term I have. N choose j of n minus j, a to the j. Okay, hopefully that makes sense. If I have here, I have n choose j of y to the n minus j, a to the j. Now you might be thinking, what is the n to the j? Okay, here's my little game. I know what n is. That's going to be 10. I want this n minus j to equal 8. And if this is 10 minus j equals 8, that means that j equals 2. So this would be y. So in this case, this is our 2y. So we'd have 2y to the 8th, because the 2y goes apart with it. And we're trying to find the coefficient. And this would be times our 3 to the 2nd. There's our n, here's our j, here's our n minus j. They all go up to 10. So 10 choose 2. And really, we know that this is going to come out with something to the y to the 8th. So really, if I just go to my calculator, I'm going to calculate 10 choose 2 times 2 to the 8th times 3 to the 2nd. So I'm going to go here. I'm going to hit Menu, Probability, Combinations, 10 choose 2 times 2 to the 8th times 3 squared. And that 103,680. Y to the 8th is my coefficient. Same thing. Last example. Find the 6th term in the expansion of x plus 2 to the 9th. So the 6th term would be 9. So the first term is 0. So this would be n choose 5. So 9 choose 5. Why? If I go 0, 1, 2, 3, 4, 5. Because our count always starts with the 0th term. We would do n choose 5 of x to the 4th times 2 to the 5th. Where does this x to the 4th come from? N minus j equals 9 minus 5. There's your to the 4th power. So 9 choose 5. I'm going to go Menu, Probability, Combinations, 9 choose 5. X to the 4th doesn't change. And then I'm going to do times 2 to the 5th, which is 32. I get 4,032 x to the 4th. That is the 6th term in that expansion. So hopefully these problems make a little more sense. Again, if you need any further explanation, please let me know. And then we are on to our last section for my seniors. All right, see you next time.